Welcome to this demo of how to use the SWAN service to run Apache Spark applications using CERN resources and in particular attaching to CERN Hadoop clusters. The first thing we want to do is to attach our configuration to the Hadoop. So here we have the configuration pop-up menu from SWAN. So we'll keep everything default and we'll select the general purpose Hadoop cluster called Analytics. Okay, we are here in my projects space. Spark Training is the repository with the notebooks and data. We go on the notebooks, demo Spark on Hadoop. So the kernel is starting up. So this demo will be about querying some data, monitoring data that is stored in HDFS. We'll be querying it using this notebook, do some plotting as well. So the first thing we need to do is to attach now to the analytics cluster. So our configuration is set up so that we can do that. And we can add additional Spark configuration if we want to. We just choose everything default. What is happening now is the Spark connector in the CERN SWAN service is now creating for us a Spark session connecting to the Hadoop cluster called Analytics, contacting Yarn, and getting all the resources that is needed. Okay, we have our Spark session. Here we can see the Spark version, and the Spark History Server link is also available. Okay, let's go back to the notebook. We just need to run some import. And then we define a data frame reading monitoring data that is stored into this Hadoop cluster at this particular path. What pops up now is the Spark monitor integrated with Spark on SWAN service that shows us the progress of the various jobs that we run on Spark. Okay, this is the schema of the data. Just map it to a temporary view, and then we run a select statement, so we query data from this Parquet table that we have. The Spark monitor shows us the progress of the job, also shows us how many resources we are using, how many jobs are running, and the elapsed time for the jobs. So the result of the query will be put into a pandas data frame so that we can then use standard Python tools for plotting. Okay, the jobs is completed. So since we use dynamic allocation, the number of executors has ramped up to 9, and so 36 cores. So now we are back into standard Python work. So we just plot a heat map showing the load average for the various servers over time. Okay, this is just for demo purposes, so we don't drill down in the data. So another short demo is again on reading data stored on the HDFS system. And this time we want to query the uptime of various servers. And again, we will put the results into pandas. So our query is running. Spark monitor it tells us the progress of the query, how many tasks have been run, how many need to be run, submission time. Then we see the resources that are being used. You can also click on this tab and you can see the executors that ramp up due to dynamic allocation. Okay, the query is completed. Now we can visualize the results. Ignore the warning. This is the histogram of the uptime. Okay, and this terminates this demo. We can stop the Spark session. Thank you for watching this.